Hello all. In our previous lecture, we started talking about material handling equipment, and in this one we will continue talking about the material handling equipment. In the previous lecture, we talked about the classification of material handling equipment. We talked about containers and unitizing equipment. We started talking about material transportation equipments, and we talked about the conveyors. In today's video lecture, we will continue our discussion on material transportation systems. We will talk about storage and retrieval equipments. We will talk about automated data collection and identification and communication devices in this lecture, and we will complete our discussion on material handling equipment. So let's start. In our previous lecture, we talked about the material handling equipment classification, and we divided the material handling equipment into 4 categories. Basically, we said containers and unitizing equipment, material transport equipment, storage and retrieval equipment, and automatic data collection and communication equipment. And we talked about containers and unitizers, and we talked about conveyors as the material transport equipment. So today we will start with talking about industrial vehicles. Industrial vehicles are variable path equipment. So in opposite to conveyors, which are fixed path, industrial vehicles are variable path equipment, which means that they can go from any starting point to any other end point as long as there are suitable with aisles in between. Industrial vehicles are used generally when movement is intermittent, not continuous, but from time to time, occurs from time to time. And usually when it is for long distances, so that installing a conveyor in between these two endpoints is very costly. We can further classify industrial vehicles into subcategories. So we can talk about walking industrial vehicles, riding industrial vehicles, and automated industrial vehicles. We will see each one of those. The basic advantages of industrial vehicles are they do not require to follow fixed paths, they are variable paths. They are capable of making different material handling operations. These include loading of the machines or storage racks, unloading again of the machines, the storage racks, and etc. Lifting up a load, and also, of course, transferring the load. Okay, so for example, for a conveyor just transfers the load from one location to another. In order to load a part onto a conveyor, you need to lift it. Maybe at that time you need an operator or an additional device so that it places the load onto the conveyor, so that it makes the transfer. But in the case of industrial vehicles, these vehicles are capable of loading, capable of lifting the loads by themselves and transferring. And due to this flexibility, they are highly utilized, even if in highly automated systems, which include longer conveyor lines. Still you need some variable path devices. You still have at least one or several industrial vehicles. What are the basic disadvantages? They cannot handle very heavy loads. Of course, they have different capacities. They may be smaller ones, large ones, and the large ones are capable of carrying or handling heavier load. But still, industrial vehicles compared to others, for example, hoists and cranes and etc., they cannot handle heavy loads. Per one trip, they have a limited capacity, so they can, for example, a forklift can transfer a pallet of loads in one trip. Okay, so or you can stack a number of pallets on top of each other, but still there is a limited capacity. Usually, in most cases, these industrial vehicles are driven by an operator. It means that they are manual and you need to allocate an operator for these transfers. Although there are some automated transfer devices, in most cases they are driven by an operator. And in one of the advantages of conveyors, we mentioned that during the transfer, uh, you can perform some operations like inspections or small operations. But with industrial vehicles, it is usually not possible, so that combining the handling operation with processing is not possible. Vehicles was the walking industrial vehicles. Basically, an operator uses these devices. In some cases, even with the manual power, they are operated. But in some cases, they have their own motor, but still an operator drives these vehicles by walking along with them. So the basic one is operated by manual power, is the hand tracks or hand carts, an example like this. So we may have platform trucks like this. These devices has their own battery and has their own motor, but the thing is the operator drives these vehicles and walks along with that vehicle. It can be pallet jacks like this one, so it is similar to forklift, so that you can take pallets on top of this pallet jack and again drive it. Or bulky stackers like this one, so that you can lift the load up and you can place it on higher racks in storage systems. Okay? These are the basic walking industrial vehicles. In the second category, instead of walking along with the material handling device or the industrial vehicle, the operator rides on the vehicle and drives the vehicle by riding on it. Basic ones or some examples include pallet track, for example this one. So remember the first category, you have this walking pallet track. It is a modified version of that. Basically the operator rides on this and drives by riding on it. It can be a tractor trailer, counterbalanced lift truck, or forklift truck. Okay, so this is a tow tractor. So basically, it tows a number of carts on it, behind it, so that it can drive. The operator can drive them. So it can be a counterbalanced lift truck. Again, we have seen the walking version of this, and this is the driving version. Of course, when you want the operator to ride on the device, you see you need additional mechanism so that it's possible to drive these vehicles, and also you need to have some space for the operator to ride on. It means that the devices are expensive, becomes more expensive, but instead of walking along with, since the operator rides on these devices, it can be faster, it can be more ergonomic, it can be safer for the use of operators. The third category of industrial vehicles is the automated versions of these industrial vehicles. So every device that we have seen until now that are operated by workers can be automated. Okay? So for automated industrial vehicles, one category, important category, is the automated guided vehicles, AGVs. And we may have unit load carriers, small load carriers, or heavy load carriers, towing vehicles, assembly vehicles, and storage and retrieval vehicles of AGVs. we may have automated electrified monorails, and we may have sorting transfer vehicles. So it's important to know the advantage and disadvantage of these devices, and there are in fact different technologies of these AGVs. For example, these AGVs, how are they operated? They can be, for example, AGVs which are pre-programmed so that they follow a code, a computer code, or they can be instructed online so that whenever there is a need of material transportation, a central computer sends the command to the AGV. Of course, this central computer plans all the AGVs inside the facility. There may be in some cases hundreds of AGVs. If you have seen the warehouse of AliExpress or Amazon.com, there are a lot of smaller AGVs that carries the items to pick up locations. So a central computer schedules and plans the path of these AGVs and sends the command through an online or communication system, and the AGV follows the path through this system. And some of the AGVs may follow laser beams or may follow a line, painted line on the floor, or some of the AGVs are just free moving AGVs. They use some kind of a GPS system and position itself inside the facility, and it can identify its environment, it can identify the aisles, and it can go through these aisles. Of course, security is very important with these AGVs because whenever it's automated, there is no operator. So when it's going to hit into something, it's going to crash into something, or maybe even worse, it will hit into a worker, then it may be dangerous. That's why there are a lot of sensors on these AGVs so that in case of emergency, they stop automatically, or they have emergency buttons so that someone can stop it in such cases. So this is an example of an AGV, which is similar to the forklift. Okay, so this is a fork truck AGV, which can handle, which can lift pallets and transfer the pallets. This is an small load AGV. So why it's called small loads? Because it can carry smaller loads. Okay, that's why it's called small load AGV. And you see there are sensors in front and etc. So it can carry these loads inside the facility. This is an example of a medium load AGV. You see it is size is larger than the small load AGV. And you see it has bumpers so that in case of crashing or hitting into something, the AGV itself is not damaged, and also the person or the other AGV is not damaged. And there are also sensors all over this AGV device. This is a heavy load AGV. You can see the size of the AGV, and it can carry higher volume and higher weight items. The work principle is the same. This is an AGV towing vehicle, so the load is not on the AGV. It doesn't have fork, it is not like forklift, so that it's not lifting the loads, but the loads are placed on other carts, and this AGV just tows those carts behind. Okay. This is a storage retrieval AGV. So again, inside your warehouse or inside your storage facility, there are racks, and whenever you need an item or whenever you want to store an item, this AGV can take the item directly to the assigned address in the storage and place the pallet or the unit load into that address by itself automatically. This is an example of an automated electrified monorail. You see these devices, move along a rail, and they are electrified and they are automated. So whenever it's necessary, they can stop. Whenever it's necessary, they can move along, and also maybe they can transfer from one line to another at intersection points. And this is an example of a sorting transfer vehicle. The thing is, for example, this side can be your storage system, and this side can be your door of the warehouse, so that each line over here is assigned to a specific customer. So the truck for that customer approach to this door. Okay, so when an item is collected, that needs to go to this customer one over here. And if the item collected for that customer one comes to this line over here, then the devices here, you see these devices can move on this axis so that they will take the unit load from this line and move to this line and drop it to the first customer. So depending on where the loads will go, these sorting devices can take it from this side and move along and place it on the necessary line. Okay, so this is an example of a automated sorting device. After conveyors and industrial vehicles, the third category of material transport equipment we will talk about monorails, hoists, and cranes. Basically, we will talk about monorails, hoists, and cranes. And under cranes category, we will see examples of jeep crane, bridge crane, gantry crane, tower crane, stacker crane. Okay, so these are several examples of cranes. The advantage of these devices are they can be used for lifting as well as transferring of the materials. They can carry heavier loads in comparison to conveyors and industrial vehicles. And they can perform loading, unloading operations. When I say loading, unloading, you should think about loading, unloading of machines, loading, unloading of storage systems. Okay. And basic disadvantage of these devices are they require large investments. They are expensive in comparison to conveyors and industrial vehicles, and they require large initial investment cost. Usually they serve a limited area, especially for example jeep cranes or bridge cranes. They can serve only a very limited area. And another disadvantage is usually their utilization is not very high. They are used only for short periods of time. Now let's see some examples of these. This is an example of a monorail. You see the rail is at the top of the facility. It means that you can use the third dimension for this. And you see these monorails are carrying these engine blocks and they carry over the rail. Okay, so this is an example of a monorail and it can carry heavier loads. You see they are hanged on these monorails and these monorails move along, these loads move along these rails. This is an example of an hoist. It is the top of a hoist so that you can hook the load and it can carry the load up, and it can move along again also like monorails to move the load, not only for lifting but also for transferring the load. This is an example of a jeep crane. You see there is a central let's say column of this jeep crane, and you can hook the load onto this jeep crane and it can turn around and carry the load. You see in action. It has lifted a load, and the operator usually operates these devices with such a commander. Okay, and then it can move along this axis, and it can turn around so that you can carry the load. But the thing is, you see, it can serve a very limited area. Okay, now you can see examples of bridge cranes. You see in bridge cranes, this is the crane, or this is the crane, and it moves along again these rails on these two sides. So there are rails over here and over here, and this crane moves along these rails, okay, at the top of the facility, and it has a hook so that it can lift the load, and it can move the load along this axis, and also it can move the load along this axis. It can have radio control, or it can be controlled through a pendant. Okay, so this is an example of bridge crane. This is very similar to bridge crane, which is called gantry crane. In bridge crane, the rails were at the top of the facility, so only this part was moving along the rails. But in gantry cranes, you see the rails are at the bottom, and there are wheels on the crane, and this whole crane moves along this axis. So it means that you can use these gantry cranes in open air. You don't need to have a facility like the bridge cranes. This is an example of a tower crane. Can you see, especially for lifting the loads too high, you can use tower cranes, and they can they can lift heavier load, and they can move the load along this axis, and also they turn around themselves so that they can transfer the load to different locations. And we usually see tower cranes in constructions of buildings. You can see along Muscat as well these tower cranes. And finally, this is an example. These are examples of stacker cranes. They are similar to storage equipment, storage and retrieval industrial vehicles, but they can serve heavier loads and for storage systems which are very high and long. So you see this stacker crane moves along these rails, and it can store and retrieve these loads from the addresses. Again, this is the crane over here, and these are the storage racks in two sides, and this device can store or retrieve items from both sides. The third class that we mentioned about material handling equipment was the storage and retrieval equipment. Basically, we can divide it into subcategories as unit load storage and retrieval, and small load storage and retrieval. So we will see examples of these. For unit load storage and retrieval, we can talk about unit load storage or racking equipment. We will see examples of these. So block stacking, pallet stacking frame, single deep selective rack, double deep rack, drive-in rack, drive-through rack, pallet flow rack, pushback rack, mobile rack, and cantilever rack. We will see each one of these. And also, if you want to see them in action, please go through YouTube and search for these names, and you will see each one of them in action. And other than storing, we can talk about unit load retrieval equipment. And remember, in the first one for industrial vehicles, we talked about walkie stackers. So we can put that into this category as well, walkie stacker. Counterbalance lift truck, we also mentioned this in industrial vehicles, narrow aisle vehicles or straddle tracks, straddle reach track, side loader track, turret track, and hybrid track. These are narrow aisle vehicles. And automated storage and retrieval machines we can talk about. So let's see some examples. This is an example of block stacking. You see these are the loads, and these loads are placed on these stacking block stacks so that you can put them on top of each other using a forklift so that they can be stacked on top of each other, and you save from space with this way. So if you stack all these cartons on top of each other, after some weight, after some number of load, the bottom ones will be damaged. So in order to avoid that, you can divide them into certain allowable numbers, and then you can stack them using these block stacking systems. This is an example of pallet stacking frame storage. You see the bottom it's a pallet, and you have these let's say frames for these pallets so that you can place them on top of each other without damaging the loads. And if you want to carry these loads, you can just carry with these, you can just carry these pallets, and you can place these racks by using these frames. This is an example of single deep selective pallet rack. So these are the racks, and it is called single deep because you see the storage and retrieval equipment moves along these aisles, okay, and they loads and unloads the items on this side or on this side. But you see they will place, there is a place only for one pallet or for one unit load in each side. That's why it's called single deep. So the pallet or the item here will be loaded from this side, and it's not reachable from the other side. It's single deep. And since it's single deep, it means that if you want to take an item or place an item, you can reach each of these items without moving the other ones. So we will see, for example, double deep racks. In double deep racks, you are placing on these racks two items on the same rack. And if you want to take the one which is inside, you first need to take the one which is outside and then take the one inside. But here you can reach to anyone, okay? You can reach to anyone. That's why it's called single deep selective pallet rack. These are very common. These single deep selective pallet racks are very common, and that's why they are named as the benchmark storage modes. Okay, you can always compare the performance of other storage systems with this one. That's why it's called benchmark. Due to rack supports, each pallet is independently accessible. Okay, that is, it supports totally random access. As I explained, you can store and retrieve any one of the items directly, any one of the loads directly. That's a good, that's an advantage, that's a flexibility of this system. But the trade-off to this flexibility is you need to have too many aisles in order to be able to reach every item as you like. You need to have aisles at very frequently, and it means that you have an inefficient space utilization. This is the trade-off. Now, when you see an example of double deep selective pallet rack, it will be clearer to understand this single deep. You see, in double deep system, on this aisle, on the rack, there are two places to place these unit loads, in this case pallets. Okay, so this is the first unit load, this is the second unit load, and for example, if these loads are different from each other, then in order to reach to this one, then the retrieval device first needs to take this load, place it to somewhere else, and then take this one. Again, in order to load to inside, it first needs to place this one, then place this one. And also the material handling device should be suitable to reach to this deep. Okay, so this is a double deep selective pallet rack. At each aisle, at each side, there are two places for locating these unit loads. So in these double deep selective pallet racks, there are two selective racks placed back to back. So they are two deep lanes. Each lane is dedicated to one SKU, one stock keeping unit. SKU means stock keeping unit. Okay, so space loss in case of SKUs with odd number of pallets. It means that if you don't place two pallets in these racks, which means that one space will be empty, so your utilization will be less. But it reduces the aisle space requirements. In some cases, it may lead to 50% savings in aisle space, because in the previous case, for single deep pallet racks, you need to have an aisle for every rack. But here, you need to have an aisle for two racks on the left and two racks on the right. On the other hand, the trade of this saving is you need to have more work, and you need to have specialized equipment for retrieving. As I said, your forklift device or retrieving device should be able to store and retrieve the items from the inside storage place, from the second lane. So it should be a special device for that, and usually these devices are more expensive. In order to utilize the storage system, the space of the storage system better, more, an alternative is to have a drive-in rack. And you see in this drive-in rack, we have these racks placed, like for example, we had single deep, double deep. Here we have many deep we can consider, but the loads are placed into these racks so that the storage device can go into the rack. You see, this is the column here, and the storage device, the retrieval equipment or the forklift, goes inside the rack and loads and unloads, or stores and retrieves the unit loads by driving in the rack. Okay, that's why this is called drive-in rack. The space utilization is better here, but of course, again, if these loads are different from each other, then in order to reach a load in the middle or at the bottom, at the deepest lane, you need to take all the load, okay, and then you can reach it. Similar to a drive-in rack, this is a drive-through rack, and in this drive-through rack, the items, the stored items, can be reached from both sides. And again, the device, storage and retrieval device, can go inside the racks to store and retrieve the items. Usually in these drive-through or drive-in racks, the racks have 5 to 10 loads deep. And as I said, and as it is evident from the shapes, you have better space utilization with these type of racks. But storing and retrieving items is more difficult when you compare with single deep or double deep racks, and sometimes even it can be dangerous to retrieve items from the inside, from the deepest lanes at the top rack, for example. It can be dangerous. You can drop the unit load. Another alternative is to have pallet flow racks, and in these pallet flow racks what you do is you place the you place the unit loads from one end, and then with the help of gravity, because there is a slope down here, with that gravity and with these rolling conveyors or wheels, the loads or the pallets come to this side, to front. Okay, so you place the unit loads from the other end, and you retrieve them from this end. You may retrieve, or you can also retrieve from the other end, but the thing is, you don't need to have your storage and retrieval device to go inside the rack. With the help of this gravity and with the help of these wheels, they come through this side automatically, and when you, for example, take this unit load from this side, all other loads will move again to the front side. A similar idea is to have pushback racks, but in these pushback racks, instead of placing the items from one end and retrieving them from the other end, what you can do is, again with the help of gravity, these items are pushed to this side, but slide to this side. And if you want to store a new item, what you can do is you just lift the item and push all others back and place this one here. So they can be pushed back and the item will be placed here. And for example, if you retrieve one item from here, all others will slide to the front. Okay, so you are storing and retrieving from the same same side of the racks. These are called pushback racks. These pallet flow or pushback racks are slanted and have rollers, and because of these, every time a pallet is retrieved from a lane, all the pallets behind it slides to the front and takes its position. Okay, so this kind of storage system allows simultaneous picking and restocking. For example, you can place one pallet from one end, you can take one pallet from the other end. This supports FIFO operation. FIFO means first in, first out. This is especially important if your items are perishable or if your items have a due date for usage. For example, in drive-through systems or drive-in systems, you place an item, let's say, onto the deepest lane, and then if you place more loads in front of that deepest lane, then when you reach an item, you take from the closest lane, right? And in order to reach to the deepest lane, maybe you will reach it months later, and if there's a due date for that item, it will be retrieved, either it will be retrieved very late, or in order to take it back, you need to first retrieve all the items in front of it, and then you can reach it. But in these pallet flow and pushback racks, you are loading an item from one end and you are taking from the other end, so that the retrieved item, the item that you are retrieving, is the first item that you placed, meaning that you are using the older items first. Okay, so this FIFO operation is supported by pallet flow, not pushback ones, but pallet flow ones. And usually these kind of systems are typically used in high throughput facilities. Another idea or another type of racking systems used to save from AL space is the so-called mobile racks. And you see these racks over here have their wheels and they can move along these rails. And whenever you need an item in one of these racks, basically you can hold the whole rack and move it to this side until you reach the rack that you want, and then you can take the item, especially in libraries, or you can see this even in the bookstore here. So these racks, using these wheels, you can move along the rails and you can reach the rack that you want. And by this way, instead of placing an aisle in front of each of these racks, you can have just one rack, you can have just one aisle, and you can reach to every one of them. So this is better for space utilization. Another type of storage system is the cantilever racks. You see, in cantilever racks, in fact, you don't have a platform on these racks. You have just these, let's say, frames, and you can support your, you can store your loads on these frames. But of course, the loads that you are storing must be suitable for this purpose. You cannot store every kind of load onto these cantilever racks. But for example, you can store long beams or wood on these frames. So it's suitable to use with this kind of loads. The advantage of cantilever racks, of course, it is cheaper when you compare with other racks, easier to install and cheaper. But as I said, on the other hand, it is difficult. Not all load types are suitable for this type of racks. After talking about these racks and unit load storage equipments, we can now talk about unit load retrieval equipments. In order to select your unit load retrieval equipment, or in order to compare their capabilities of different unit load retrieval equipments, we should consider these factors. What are the aisle width requirements? What should be the width of the aisle so that a specific retrieval equipment can operate? The lift height and weight capacity of the equipment. Lane depth that they can reach. So is it possible to reach to the second lane so that you can you use double deep lanes or single deep? They can only reach to single deep. Degree of automation, do they need an operator to work? Is the operator walking with the item or driving the item, or is it just an automated system? And the capital expense that is required for each one of these items. The major types of these unit load retrieval equipments are walkie stackers, counterbalance lift trucks, narrow aisle vehicles, and ASRS machines. So let's see some examples. This is a straddle reach truck with scissor mechanism. You see, this is the scissor mechanism. So if you have deeper lanes with this scissor mechanism, it can be extended so that the load inside the deeper lanes can be carried, can be moved. But of course, because of this scissor mechanism, it may not be able to hold heavier loads. This is a side loader. A side loader means basically the operator or the moving lane, moving direction and loading direction are 90 degrees at all. Okay, so you see this is the driving direction and the load is carried on the side of it. That's why it's called side loader. And the basic advantage of side loader is it requires a narrower aisle. You don't need to make a turning maneuver here. You can just load and unload and carry the load on this aisle. And this is an example of a unit load ASRS system. You see in this ASRS system, it's automatic control, automated storage and retrieval system. and you see the racks are very high and very narrow aisles, and these automated storage devices are assigned to each aisle. So this ASRS device cannot go out from this aisle and enter into this one. At each aisle there is a certain device that's operating. They are very fast, they are automated, and they are instructed by the computer. Okay, and no human operators are allowed inside these systems because it's dangerous. So we talked about storage and retrieval equipment, and until now we talked about the unit load storage and retrieval equipment. So when I say unit load, it means that a number or an amount of parts are stored in a container or on a pallet and etc. Now we are going to talk about small load storage and retrieval systems. Basically, in this category, we have smaller items that are stored in the system, and basically we will talk about operator to stock storage equipment. In this one we will be talking about the bin shelving, modular storage drawers in cabinets, carton flow racks, and mezzanine. In operator to stock retrieval equipment, when we say operator to stock, it means that in order to in order to store the items or retrieve the items, the operator goes to the stock address. Okay, that's why it's called operator to stock. In stock to operator system, the operator stays in a pickup location, and with a mechanism, the stock items are coming to this location, and then operator collects the item that he needs to collect according to the customer orders. Operator to stock retrieval equipment, we will be talking about picking carts, order picker truck, person aboard automated storage and retrieval machines. And finally, we will be talking about stock to operator equipments. We will be talking about carousels, which can be horizontal or vertical or independent rotating racks, mini load automated storage and retrieval machines, and vertical lift module and automated dispensers. This is an example of bin shelving. You see the items over here are not unit loads, which means that they are not they are not collected on a pallet or in a container. Basically, they are smaller items, and they are stored with either their carton packages or boxes. Okay, and in this system, basically they are stored in these bin shelves. Another example is a modular storage system, drawers in cabinets. So these are drawers, and basically the items are stored inside these. They are very small units, and whenever you need to collect an item, you basically pick up or store the item inside this drawer cabinet. Another system for small load storage is the carton flow racks. In fact, this is similar to the unit load flow racks for unit loads. Again, in a similar idea, there are rollers on these racks, and when you place an item from the back end, with the help of gravity, it slides to the front. So the cartons are placed one after another, and whenever you use one carton from the front, when it's finished or removed, all others slide to the front, and this facilitates the use of first in, first out system. Another example is mezzanine. Mezzanine is this using the third dimension, the height of the system, so that increasing the space utilization. So you can store items here and as well as here at the mezzanine, and you can place different type of racking systems in the mezzanine, which increase utilization for space usage. Now let's see some items to collect the parts from the small load storage system. So we will see some operator to stock retrieval system. This is an example of a mobile pick cart. Basically, it has some wheels and the operator just drives this pick cart. And whenever it reaches to the correct address, then it takes the part from that address and places on this pick cart. These pick cards can have different features. For example, in this one, you see there are smaller screens over here. It means that in order to ensure that you are collecting the correct item according to the customer order, you have to read the barcode or the RFID tag of the items. And again, not only the correct item, also collecting the correct amount of item is important. So what do? You read the item from this screen. Maybe you can see which item you are going to collect. In some cases, in some pickup cards, you can see. Or what do? You just get the item and read it into this space, and you know that this is the correct customer order, and with lightning, green or red lightning, it indicates if it is the correct one or not. So with a milk run, we call it a milk run, you have a list of items to be collected, like a supermarket list. Okay, so you go into the warehouse, collect individual items on this cart and return back. So this is like a supermarket cart. This is an example of an order picker truck. Basically, if your storage system, the height of your storage system is larger, you cannot just collect them from the floor. Then you need a device to go up. And in this system, basically, the operator is lifted up and it collects the items according to customer orders using this picker truck. This is another example which is called person aboard ASRS. You see the person is on this ASRS system and it visits the addresses to collect the customer orders or store the items into the correct addresses. These talk-to-operator systems have certain advantages. Most important of these advantages are they have higher productivity. When we call productivity, you can think about this. In a certain amount of time, in one shift or in 1 hour, how many items you are collected? Okay, you collected. This can be a measure of productivity, and usually these stock-to-operator systems have higher productivity. They have easier supervision. You just create an order list and give it to an operator, or a computer instructs the ASRS system to collect these, and supervision is usually easier. In these systems, you have better item security and protection, so you are always aware of the items. The items stay in their addresses, and only the order pickers go and collect these items. There is a parallelization opportunity, which means that you can divide the customer order into two parts, and two different collectors, two different workers can collect the order at the same time. And in this system, you focus on extraction rather than traveling and searching. There are basic disadvantages on the other hand, which means that these systems are usually more expensive. They require more maintenance, and to reconfigure these systems, it's more difficult to reconfigure. Another idea to store or retrieval items is, instead of moving the operators into the stock, you bring the stock in front of the operator to collect. Okay, so in case of operator to stock systems, an operator, for example, can start from this point and visit this address to take one part. then visit this address to take another part, then to here, to here, to here. So it visits the whole warehouse, and usually these warehouses are huge and you may need to travel a long distance. But in stock-to-operator systems, basically these racks uh, are movable, so they turn and the operator stays just here at the pickup location for each rack, for each carousel mechanism. This is called carousel. There may be one pickup location, and as soon as the required address, the required rack is in front of this pickup location, the operator picks up. So the travel distance for the operator is minimized. So these are some examples of horizontal carousel systems. You see these racks turn around, okay, on their axis, and on the pickup location, whenever a certain address, certain rack is in front of the operator, it collects the required amount of items from that rack. Similar to horizontal carousels, we may have vertical carousels in which the racks, the items are placed on the racks, and the racks are turned on a vertical axis. So that again, the operators collect as soon as a rack is in front of them. So you see this is a vertical carousel. Usually they are closed, only a certain window is open, so that when you ask for a rack, it automatically brings that rack in front of you and you collect the items. So finally, we will see some examples about the automatic data collection and communication equipment within the classification of material handling equipments. We will talk about automatic identification and recognition and automatic paperless communication devices. For automated data collection and communication, for identification and recognition, you are all well aware of barcoding systems. So it can be barcodes, and now we have square codes, in which square codes you can store more information. And of course, when you have barcodes, you need to have barcode readers. In fact, we will not go into too much detail of these technologies. If you are interested, you can search for it. But the main thing is you need to be aware of these technologies and how you can use these technologies. Optical character recognition is another method of automated identification and recognition. Radio frequency tags, RFID tags, which can be active or passive. In active case, it operates with a battery. In the passive case, it doesn't have a battery. It is just a label, and it just returns an answer to a signal. There can be magnetic strips, or we can use machine vision to collect data or identify the parts. Barcodes are widely used because they are cheaper. You just print a barcode, or as I said, now as the new technology, instead of these barcodes, we have square codes. Okay, there are different standards for barcodes. For example, this is a 2 of 5 interleaved 2 of 5 code. This is a 3 of 9 code. In each of these standards, you represent the alphanumeric characters and decimal digits with thin and thick lines and empty spaces between them. Okay, so these are some samples. This is the Universal Product Code, UPC, for example. And in this UTV, it's a 10-digit barcode. Okay, it's adopted by US grocery industry and in all over the world. These are examples of some barcode scanners. You are all aware of these devices. When you go to a supermarket, you see both of these devices. This is a handheld barcode scanner, which is mobile, and you can extend it to read the barcode. And this is a stationary one. Again, both versions are you can see in supermarkets. Usually, the initial versions of these barcode readers are in single directional. So it means that it sends a laser beam, and this beam should be vertical to the barcodes in order to read it. But in that case, you need to arrange the orientation of the part to be able to read, and sometimes it's difficult to do this if the part is especially heavy, or if you want to read the barcode on a conveyor, so it creates problems. And in the new technology, we have omnidirectional barcode readers, so it sends the laser beams in this form so that whatever the orientation is, it's possible to read the barcode information. Communication is also very important in material handling, and there are several automated communication mechanisms which does not require papers. Most important of these are radio frequency data terminals, RF terminals, voice headsets, light and computer aids, and smart cards. And in order to facilitate the material handling, in order to, for example, in a warehouse to collect the correct items, and in order to identify if the item is collected or not, or in order to instruct an operator to collect an item if the operator is already in the field, then you may need such communication equipment. These are two examples of industrial communication devices. The first one is a handheld RF terminal. The second one is a wrist-mounted RF terminal. And for example, you can get the list of items to be collected, or you can approve that an item is collected, and etc. By using this device. And the thing is, currently, in fact, you don't need such industrial devices. You can perform all these tasks using the mobile phones. But of course, there are some drawbacks of using personal phones for this purpose. It may have security problems, the battery life of the mobile phones are problematic, and etc. Therefore, still such industrial devices are important. This is an example of an RF terminal which is mounted on the truck itself. You see, in order to collect the items or store the items, you transport the items, or you came to the address of the items, and then using this truck mounted terminal, you read the barcode and you are sure that it's the correct address, this is the correct items, and you collect it. So we covered only a number of material handling devices, only some examples of these devices, and there are many other alternatives out there. You can even search in the Google or YouTube to see the newest versions, the new technology items, and etc. And as we said previously, the material handling designer, in order to design a material handling system, you should be aware of the new technology, you should be aware of the technology and the devices that is out there, that's in the market. Okay, and then we also mentioned that in order to select the material handling equipment, it is because of the number of alternatives, it is a difficult problem, and there are many restrictions regarding your design, regarding your system, what is the items that you are going to transport and store, what is the dimensions, what are the dimensions, what is the weight, what is the volume, what kind of storage system is required. There are many combinations, many alternatives. So the thing is, since there are a lot of alternatives, you need to somehow reduce the set of alternatives by considering the restrictions, so that you have only the feasible alternatives on the material and the move. Okay, so since there are a lot of alternatives, you need to rely on judgment and experience. Of course, if you are new as a designer, you will not have too much experience, but as you do such designs again and again, you will have more experience. We can say that generally no single alternative is superior to all other alternatives. It means that you may have different designs, totally different designs, and these designs may perform equally well. You cannot compare them to each other. You cannot select one of them over the other. There may be several good solutions. So you should look at this material handling equipment selection problem as a satisficing problem rather than an optimization problem. So you need to select the equipment that satisfies your needs. Okay. So this is what we will cover about the material handling equipments.